All right, so you've heard of microservices and you've heard of monoliths, but have you ever heard of microliths? Today I'm joined by Jaxon Repp, Field CTO at Harper. Let's jump into microliths. What is a microlith as it pertains to software architecture?
Well, it's actually a portmanteau of two technologies that most software architects are extraordinarily familiar with. Microservices, wherein we separate all of the concerns in an application into their own discrete applications and allow them to communicate via some trust mechanism to accomplish the larger goal. Monoliths, by comparison, are applications that ship in their entirety out to wherever they're going to run, and may have multiple pieces and services all sitting in one code base. The advantages and disadvantages of each are topics of philosophical debate for decades. But in general, you can think of the older, more established monoliths as how we used to think as humans, like everything that I need is right here. It's easier for me to wrap my head around it. It is easier for me to manage. However, there are disadvantages to it in that if I want to update one part of it, it requires that I deploy the whole thing again. So microservices then, by contrast, are all of those individual components or tasks that do something in an application, separated out into individually deployable components. So think multiple Docker containers, for example, each of which handles something like a UI or even a part of a UI, right? A micro front end. And then APIs that may have different domains. So this might be my product container implementation that talks to the product database. This might be my inventory that talks to my inventory database. And all of these are interacted from the UI, for example, by individual authentication calls. And they are very separate. Again, the advantage to that is that you can deploy one container without perhaps redeploying your database or the APIs that power it. Microliths, then, are a phrase that we at Harper have coined to kind of describe our architecture, wherein Harper is a comprehensive platform that is comprised of a database, an in-memory cache, interfaces to interact with via HTTP or real-time protocols, and then a programmable application layer that is powered by components. So if you think about this, we can deploy Harper, the platform, once, and then we can deploy microservices on it. And the reason there's an advantage of that architecture, at least in our opinion, this microlith, is that our individual components can still talk to each other, but they're doing it in function space. They're not making over the network calls. They're not communicating via IP addresses. They're not adding to network noise. They're more secure. It's very hard to have a man in the middle attack if there's no middle, but they're still individually deployable. So you get all the benefits of microservices, but you have all the performance advantages of having everything run in one space. So ultimately, we think it's a massive advantage, and we've borne that out time after time with a whole bunch of use cases, which I'm sure you can look at on our site, which show that from a performance, security, and total cost of ownership perspective, this paradigm is much more advantageous than microservices, and certainly the monolithic deployment requirements of a monolith itself.
So it seems like kind of a really new approach to system architectures. What are some of the considerations architects should be looking at when they're considering moving to a microlith?
There are lots of ways to construct microservices. So if that's where you have been, because we have been preaching that microservices is the answer for 2 decades now,
Yeah.
there's a very real chance that many of your components may be written using different languages. So when you are moving to a microlith strategy, trying to find the underpinning technology or platform that can run all of your services if they are written in different languages may be somewhat challenging. We are Node.js focused. We understand that the broad spectrum of development experience is somewhat standardizing on JavaScript for its ability to run in a performant manner in the back end, and obviously for user land browser code. So we have embraced Node.js as our development and application platform language. But if your microservices are all written in Node.js and React, Harper is an ideal platform. If you are using lots of other services, there's no restriction saying that you couldn't still have your Python or Rust microservices running independently alongside a variety of components that may have been already written in JavaScript, and then port those over time. So it really is something you want to consider in terms of how fast can you migrate into a microlith architecture. We know the benefits are there, but we want to be responsible when we're helping customers decide on that move as to exactly what benefits you can experience most quickly. We're a big fan of quick wins here at Harper, and generally we work with customers to help them make this sort of architecture, this performance and cost benefit that we present as kind of our core value. We want to help you get there as quickly as we can, and we realize that technology is complicated. It's not for everybody, but for those customers of ours that have migrated, they've really seen those benefits.
Okay. So I know that one of the kind of big benefits of this microlith architecture comes to the ability to distribute it. So I know in microservices, they've been distributing that for decades now. But microliths, how do we go about distributing a microlithic system?
I think if you consider the phrase separation of concerns, which is kind of what drove microservices, we might have 100 moving parts in a modern application with APIs and domain divisions and micro front ends. And that's fine unless I want to be very close to my users, and my users are in lots of places. So, if I have 100 moving parts, but I want to be in 100 places, now I've got 10,000 moving parts to worry about. So I think one of the key advantages of this system is that all of the communication between these services in one location are handled in function space, right? No network connection at all. And then communication between regions or instances, or in our parlance, nodes of Harper, is handled by the underlying platform. So your individual services no longer have to worry about communicating to other nodes or pushing things across the wire. Instead, you just commit everything to our persistence layer, our built-in database, and then the configurations you have assigned to individual tables handle where and when that data is replicated. So it really becomes a lot simpler because every application is simply operating locally, and then configuration handles how things move between. So there's no limit to the number of nodes. We have some customers with thousands of nodes deployed globally to handle massive customer load. And really the communication between those nodes is something they don't even think about.
Interesting. So it really sounds like a huge time saver from like a DevOps perspective or deployment perspective. Is that accurate?
Absolutely. One of our paradigms is that I can deploy onto one node a new version of a component, and then that node itself will find all of the other nodes that are running that component and say, I've got a new update. Everybody says, let me drain my connections. Yes, send it on over. And we remove and add things into the cluster as that component is updated. So there's zero downtime. And ultimately, it is entirely composable, much like microservices, but with all the efficiency of shared core infrastructure.
So then, thinking about this in the real world and how this gets deployed, going from a paradigm of microservices to microliths, is this really a situation in which companies will have multiple microliths set up for individual services?
Very similar to all hardware deployments and the idea that you could run multiple applications on a host, there are absolutely going to be applications that are noisy neighbors that may take up more capacity on the underlying hardware than others, where you may need terabytes of disk space to store content and then deliver that efficiently, and that deserves its own infrastructure. The core software, ironically, can still talk to other nodes that are running on. So you may have a dependency in an application that is building things, caching it, and delivering it, running next to some SEO optimization like an early hint API, running next to a redirector application. Whereas this cluster of Harper nodes, this microlith is handling site pre-rendering and delivery to SEO bots. They are two completely separate concerns. This one is getting pummeled all day by SEO bots. You wouldn't want to interrupt that process for your transactional customer-facing application. However, I may be updating a page there, at which point, when I do that, that new content can be transferred over and replicated over into the page bank that serves SEO bots. So it's entirely possible for them to speak together. But when you talk about customers or users, clients coming in and getting data, that's where you decide, would adding a new application to this microlith impact my user experience? Are there shared data, and on what schedule do I want to move that over? And then autonomously, how does this interact with new data? Does it immediately rebuild a page? Does it serve stale wire validate and then rebuild it after the fact? So they are independent, or can be independent, when the load requires it. But most of our customers find that they can run multiple applications next to each other and update them independently. And as long as the load doesn't exceed the capacity of the underlying hardware, it becomes a single cluster to serve all of their needs.
That sounds very useful. So looking at from a customer's perspective or developer's perspective, how should we go about starting with Microlith architecture? Where's the starting point here?
I think the easiest way to see the impact something like this can have is to spin up a demo app. Go download our platform, create a template app, and see how much code has been abstracted away when you have a database and an in-memory cache and your application layer and your interfaces already built into the platform. What normally would have been you writing a whole bunch of boilerplate to connect to your database and make sure that's spun up, and all of the Terraform scripts to deploy the hardware, and all of the Docker Compose files to spin up your cluster, your Kubernetes configuration. I often see apps that are thousands of lines of code, most of which is connective tissue and boilerplate between all these components. I see production grade apps go out with under 100 lines of code because they're relying on the inbuilt functions of our platform. And that is really where the rubber hits the road. It's where I see the light bulb go off all the time. Customers will come to us and say, can you show me something that does this? And we have a bunch of template applications that are open source software to get you started. We'll download that together. We walk through it. We show the interface. We browse to it and see the UI, or use Postman and hit the API, and they see that it works. And then you show them the code, and it's 35 lines. And they're like, they get it immediately. And that really is the benefit. We're all developers here at Harper. We've set up all the production systems in all the same ways for decades, and we knew there had to be a better answer. And at the end of the day, this solution allows us to focus on writing composable, focused chunks of code that can work together, that can leverage common underpinning functionality. And at the end of the day, it's really hard to write bad code if you're only writing 35 lines. I mean, you could do it, but you have to try real hard.
Yeah. Well, thank you so much, Jaxon. Write less code. Hope that's a motto sticks with everybody here, and we'll catch you next time.
Thank you.